Okay, this video is just going to walk you through all of the formulas that you've covered up to this point. Because after you've talked about the finance section, you've really covered all of the main formulas that you're going to be using. So this first one, and just to clarify, this is a 1. So y equals a times 1 plus or minus r raised to the t power. Okay, this is used for exponential growth or decay. So depending on the situation, okay, so keywords that would kind of lead you to believe that you're going to be using this formula would be something is growing exponentially. Obviously, that's a keyword. Or decaying. Other words that you might run into instead of growth and decay is appreciate. And that means something increases over time. And something that means decay is depreciate. If I can spell. Depreciate, and that means it goes down over time. So you might hear those words also, appreciate or depreciate. Increase, decrease, those would obviously be keywords. But R is your interest. So I will have this formula on the formula sheet, but you have to know what A is. So just remember, A is always that initial amount, okay, or where are you starting? How much are you starting with? And of course, R is your rate, and common mistakes I see is people forget to turn that into a decimal, so I think you can handle it, but you know, if it's 7.2% as a decimal, that would be 0.072, right? Move the decimal to the left 2 places, and T is obviously time. So what you're going to have to decide is the plus or minus. Plus is obviously growth, and then decay is obviously minus. So if it's growing, you're going to add that rate, and if it's decaying, you're going to subtract that rate. So quite honestly, probably the easiest formula to utilize. Everything is fairly straightforward. And that's the first formula. Okay, the second one is just a general compound interest formula. And by general, I mean you're putting in money one time. Now with annuities, you're putting in money periodically, not just one time. So the key difference, and really the only difference between a compound interest problem and an annuity problem, is that you deposit with compound interest, you deposit one time. Okay, so if it doesn't say that you're putting money in every month or every year or every quarter, but that you just put in money one time, then you know that this is a compound interest problem. Okay, now P is called your principal, and that's how much money you put in initially. A is how much money you end up with, kind of your ending balance. N is the number of times that you compound in a year. Okay, so remind yourself if that's monthly, then, and you might write these down as I say them. I'm not going to rewrite all these, but if it's monthly, N is 12. If it's quarterly, N is 4, because there's 4 quarters in a year. If it's yearly, it's 1, because there's 1 year in a year, right? What else? Semi-annually is twice a year. And then T is time in years. Other things that I see oftentimes is like if N is 4 and T is 7, people type in 4 times 7, and if you do that, that's fine, but you must have parentheses around that N times T then, if you don't simplify that in your head. And then any fractions, you need parentheses around. So really, if you typed in this entire quantity not step by step, but all at once, you would need parentheses here, here, and here. So just remind yourself. And then just real quickly, the compound interest, or I'm sorry, this one below here, that the PERT equation is what I call it, P times E raised to the RT. That would be if you're compounding continuously. So I'll say compound continuously. And the only time you use this formula is if it says the word continuous. Okay, so if it says you're going to continuously compound something, then you know you're using the E base because of the continuous situation. So continuous, continuous, continuous is the key word. If you don't see that, you will not use this formula. All right, then we have the only formula with the letter M in it. So that to me kind of highlights, and M stands for monthly payment. And payment means you're paying the bank money because they're lending you money. So this is for a loan situation, okay? Keywords for a loan would be borrow. Okay, maybe you're going to borrow money, or the bank is going to lend you money. Okay, so those are keywords. M stands for your monthly payment. So if I want to know what my monthly payment is, P would be how much you borrow. Okay, so P is the money that you borrow. M is your monthly payment. I have that there. I is defined down here. Obviously, your interest rate divided by 12, and T is time in years. So again, if you're doing this all in one step, you'd want to have parentheses around the 12 times T if you don't simplify that. Obviously, parentheses around that fraction that's already there, parentheses around that entire denominator, right? And this I is really, you know, interest rate divided by 12, so that would be in parentheses. So just be really careful with the parentheses. And I promise you, if you know that you have everything set up right and you're not getting the answer, please let me watch you type in class, and we'll fix the problem that you're making, because I'd hate to see you get wrong answers just because you're typing something in. This is a lot of stuff to dump into your calculator. I recommend going step by step. Like I would take my interest rate divided by 12 right here, and then I would add 1, and then I would do 1 divided by that answer, raise it to the 12 times T, 1 minus that answer, and then rate over 12 divided by that answer, and lastly multiply by P. All right, last set of formulas then is your annuities. And the nice thing about the annuity formulas is they have to say annuity in the problem. So if it says you're doing an increasing annuity, then okay, you're using one of these formulas with a D in it. If it doesn't say increasing annuity, then, so annuity, bottom line, key word. If you don't see that word, do not use these formulas. Then the only difference between these two, and you really only have to use one always, but the D stands for how much you're going to deposit each month, each year, each quarter, whatever, and A is the money that you end with. So if I know I want to deposit $50 every month, I put 50 in for D. N is compounding, so if I'm putting it in monthly, it'll compound monthly, so that would be 12. And then everything else you know. So A is how much I would end up with after I do this for however many years. Now, if I want the opposite scenario, like I want to know how much I should deposit, right? This is how much I should deposit if I know what I want to end with. So that doesn't change. A and D are always ending amount and how much you deposit, but this I would use this formula, which would be a little bit easier if I knew what I wanted to end up with. Like, let's say I wanted $1 million, I put $1 million in, and notice that it's just this formula, solve for D instead of A. Okay, so all of these formulas are going to be on a formula sheet for you. If you always want to use this one or vice versa, just this one, you don't have to use both of these formulas. It's there for you to use if you want.